we are going to learn about a new concept called Kafka. So one-liner explanation for Kafka is that it is a messaging queue. Any real-time scenario you take, we can categorize it into two categories. One is in which we want the immediate response as soon as we are sending any request to any API. Okay. The second one is if we are hitting the API, we just need to make sure that it reached the place where we wanted to our request to be processed, and we are in no hurry that we want a response now itself. The application can take its own time, but we need to make sure that our request got processed. So for application, for example, when you want to create a bank account, okay, you might fill in the application online, offline, or anyhow, but it's not like within 5 minutes you want the account to be created. Okay, so that was just an example. So in this case, what happens when we are using API? Okay, so what is API? If you have no idea, I can provide you the link in the description. You can go and watch that video and then come, because until and unless we don't know what is the loophole in the existing scenarios, we'll not be able to identify the value of this messaging queues. So basically, if you don't want the response as soon as you send the request, you can use the Kafka, that is messaging queue. Now why you want to go for messaging queue? Because when you're hitting the request and you don't want the response immediately, that is good. So taking the advantage of this scenario, we have one loophole in the existing APIs, that when suppose you want to hit the request and that resource is down, so your request is gone because it is nowhere stored. Okay, then again you want to get database and all in picture, that is a different case. But as of now, you don't want the response immediately but the application down, so in this case your request is gone. So to handle all that kind of scenarios, we have something called message queues. Let's look into this. So try to understand the concept, don't focus much on clipads and all. Okay, so here we have three clients and one server or one other application which is serving all the clients, and it has one API exposed. Okay, it might be gate, post, anything. There is one API exposed. So client one wants to create, okay, we'll go with this account example only. So the API is for creating a account. Client 1 is sending the users information for creating account. Client 2 is sending, client 3 is sending. If it is able to handle, that is well and good, excellent. But there might be a time when either because of a huge amount of request or because of the downtime of the application, it might miss some of the request and it is not stored anywhere. Okay, so for covering these kind of scenarios, we have something called message queue. So the image that you are seeing on the screen, that don't imagine that as a Kafka queue. That is just for explanation how our Kafka queue actually looks. That we'll see in the next slide, but for explanation I'm considering this image. So here client 1, client 2, client 3 are not hitting that listener word. Suppose that is the application which creates an account. So client 1, client 2, client 3 are not hitting the listener directly. It means that even if the application is down or up, I don't care as a client. I am simply saying that this is my request, I want to create a new account, so I am placing it on the queue. So that pipe kind of thing, tunnel kind of thing, that is our queue. So all the clients will place their request on the queue, and as soon as listener is up or it has the ability to handle the request, or we can say number of requests per second. So as soon as the application which is creating account gets the capability to handle the request or is done with its downtime, it can accept the payloads or requests from the queue. Okay, so here we are simply avoiding any loss of request. Okay, now the clients which are placing messages or transactions on the queue are called as producers. So just try to get familiar with this kind of jargon, because there are n number of other configurations and various terminologies which you might be able to understand once you get familiar with this kind of terminologies at the initial phase. So the ones who are producing requests on the queue are producers, and the applications which are consuming, we call it as consumer. So it's like consumer is nothing but listening to transactions or requests on the queue, so we call them as listeners. Now here I have shown three producers, that is three clients, and only one consumer. But we can have any number of producers and any number of consumers. Okay, now if you can see, when we are processing a request, we accept a polio. Okay, so it's like if I want to create an account, I want name, age, certain set of fields. Okay, so these fields we call it as a template, or we can call it as a format in which our application which is creating a request is accepting a request in certain format. Okay, so we can call it as a schema. So when we are placing a schema on the queue, it should be like when I want okay, so again here comes a term called topic. Okay, so when client one wants to create an account, it knows which application is going to create an account, so that application specific that request specific queue, on that queue it will place the request. So there is one more what we can say action, like deleting an account. So for creating I cannot place on the same queue, and deleting also I cannot place on the same queue. Why? Because when the listener is trying to process the request, it might expect information in one format, but you are sending the deleting of account in other format. So overall what intention I have to say here is, when your intention is to create an account, it will have a different queue. When you have an intention of deleting an account, it will have a different queue. Now the differentiation of queue is based on different types of schema or format. So when you want to create an account, it should be in specific format that will be placed on specific queue, and if you want to delete an account, it will have a specific format of request, and that will be placed on other queue. So in this way, even the applications which are going to handle your request and process the request, they can, like, okay, I wanted request in this format, I got this, so this is a valid, I can process it. Why? Because if you create an account required format 1 and you are sending format 2, our listener will not be able to deserialize it, or I can say our listener application will not be able to interpret the schema, and it will skip your things. Okay, so what happens when these kind of things happen? So there are a number of other configurations around it for both producers and configuration. So here 3 new terminologies you have learned is, the ones which are producing transactions on the queue are called producers, and the one which is listening to it are called consumers. Okay, and the queue that you are placing it on is, you can consider it as a topic, but topic you cannot say it is a queue, but for now you assume that the queue that you are placing is known as topic, because there is much more concept around it, like partitions, brokers, cluster. Okay, so if this concept wise, this you can imagine using this picture. Now in specific, like how queue looks for Kafka, that I'll show you in the next slide. So yeah, this one. So this video is only for making you understand conceptually. In the next upcoming video, we'll implement this, and we'll try to produce and consume using terminals. Okay, so here you can see we have 3 producers, that is 3 clients, and 1 consumer. So it's not like only 1 consumer will be there, there can be multiple consumers, there can be multiple producers. So this big rectangle, okay, one second, yeah, this green color boxes that you are seeing, that I can call as servers in non-Kafka jargon, and all the servers are placed in some big blue box, right, that we call as clusters. So cluster will have multiple servers. In context of Kafka, we call them as brokers. So here we have 1 cluster, and that cluster is having 6 brokers. So when topic is created, okay, now I am going in specific to Kafka because overall concept you got it. Okay, now producers, that is clients, will place this their request on the topic. Now in which partition it is going, or whether consumer is picking up it or not, that has nothing to do with producers, because producers will only produce. Now in which topic it has to be produced, till there producers work, but how to place, in which partition I need to place, all that will be taken care by something called zookeeper. Okay, so zookeeper, what happens, because one cluster have multiple brokers, and each broker is like one topic, one broker, nothing like that. So a broker can have multiple partitions of different topics. So it is like uh, combinations of various things. uh, to avoid down when one of the broker or one of the server is down, we don't want the entire cluster to be broken down. So around that thing, our complete topic is divided into multiple partitions, and partitions are allocated to different brokers. Okay, so brokers is nothing but servers. I'll repeat this sentence again. When you create a topic and you place a request on the topic, it's not like you're placing on the topic, but you are placing a request in one of the partitions of the topic. Okay, so based on number of partitions you created, brokers will be given those number of partitions. So for suppose I have created 7 partitions for a topic. Okay, like when creating topic, I'm mentioning the number of partitions. So how the partitions will be assigned? For broker 1, that is server 1, 1 partitions will be allocated. Then broker 2, broker 3, broker 4, broker 5, broker 6, and one again. As we created 7 partitions, the 7th partitions will be assigned to broker 1. So that is how on the surface level partitions are allocated. But again, there are many sub levels, but as of now, okay, this much is enough. So we have producers, we have a cluster, and in cluster we have brokers. So for brokers, there are partitions allocated for different topics. Okay, now from which topic listener will be consuming, that is decided based on the load that each partition is having. Okay, so I think you are getting the concept. So consumer will consume from partitions of a topic. Okay, so here we are saying partitions of a topic. So when I'm saying we have 7 partitions, from a first partition it will take 1, then from second partition it will take the next request. So it will overall try to maintain the load throughout the partitions, and according to that each request will be given to listener. So this was a surface level introduction. Once we try to implement using the terminal, then you might be able to understand how this works. Then after the terminal, we are going to have one more video in which we are going to make use of Java to have JSON produced and consumed. And then after you see, you have understood the concept, you have implemented in terminals, you have implemented in your application, then we'll go into much depth, like each configuration that we have on the producer side, configuration side, and what types of issues that you might come across, how to resolve that. So all that will go one by one. So please subscribe and have a watch on this playlist to get the complete understanding. And if you have any query with respect to the conceptual level so far, please write down in the comment section. Thank you.